So what we have here is a 2-brush generator. This specifically came from a Phantom 3, but the later Phantom 2 also used a 2-brush generator. It looks very, very much like this, may even be completely interchangeable, I'm not entirely sure. And what we're going to do is we're going to give this a bit of a refresh. Not really a rebuild, a refresh, and what I mean by that is we're going to replace the brushes, we're going to clean up the commutator, and we're going to check it out. And the reason for that is because it is a working unit. I did test it and it does work. So we know that the armature is good and the field coils are good, but in the case of this car, I took the water pump off, and in order to do that you have to take the exhaust manifold off. Remember, this is a Phantom 3. And when you have the water pump off, it only takes one more nut to take the generator off. So it seems logical to give it a refresh while you have the exhaust manifold off. Because even though you can take the dynamo off and leave the water pump in place, you still have to take the exhaust manifold off. So again, we're giving it a refresh. You'll see right in there, there's some dirt and crud, and it needs to be cleaned out. I saw that and I thought, you know, that's just not, we just don't want to leave that in there. So and there's more of it in there. You'll notice that the commutator is pretty black from the brushes wearing into it, which isn't all that common. So what I like to do, even if you're not entirely sure that your dynamo is working or not, I like to get it on the bench and give it a test. You may have a problem somewhere else in the charging system with the voltage regulator or in the wiring or fuses or something of that nature. And you might not be entirely sure that the problem is the dynamo. So that's a good reason to give it a test while you got it on the bench. And also, it's good to be able to determine that the armature and field coils are good. So if it tests and you have some signs of life, then chances are your armature windings and your field coil windings are in pretty good shape. And you know, it's just another piece of the puzzle solved. So now I'm going to show you my testing arrangement, and it will seem a bit simplistic or a bit crude, but it's worked for me for, I've been doing this for over 35 years, and I learned this from the person that I worked for, John Dennison, and he was probably doing this for 20 years before me. And you know, there's sophisticated testing equipment that can spin a generator or an armature to certain speeds and give voltage readings and all that. And you know, that's wonderful. And I have used things like that, but the way I'm showing you how I test has worked perfectly fine for all those years, and so I continue to do it that way. I've even made up an elaborate mounting so I can put it in my lathe and spin it in the lathe at various speeds and see what kind of voltages I get there. So now when I go to give it a test, I'm going to connect up my voltmeter, and you can see that I have these terminal lugs marked. We have a plus over here and a C over here. The direction of rotation is that way. So we connect up our plus to our voltmeter, and then the negative side is the C. Then what we do is we connect a jumper wire from the C to the ground of the case. And so what's going to happen is it's going to excite itself. As it rotates, there's going to be a tiny bit of a charge that'll develop in the fields, and then that charge will be amplified by the rotation, and the faster it turns, the more voltage it's going to develop. So yeah, so doing it this way, we are putting a charge into the field coils because we have the C post grounded. So that's the end part of the windings of the field coils, and they need to go to ground in order to develop the charge. So we do that. We turn on our voltmeter. Then we use our drill. We have a socket in the drive, and we're going to drive it from the nut on the engine side, and we're going to spin it in the direction that is indicated. And you can watch the voltmeter, and you'll see we have like 28, 29 volts that it's developing at that RPM. We back off the RPMs and the voltage goes down. So the voltage output is regulated by the RPM of the generator at this point. And another thing you'll notice is you'll hear a loading on the drill, because it's actually putting a strain through the drill. So if we disconnect our field, then it'll just spin freely and it won't create a charge, and there's no loading. But then when we energize the field, you'll hear the loading. So at 28 volts, with the drill on full, we're going to get an idea of what we're doing in RPMs here. Okay, so you can see the voltmeter. Hopefully you can see the tachometer as well. Right here, where my thumb is 400. So under load, we're I think about like 410 or so. Under load. Now when I disconnect the field, you'll see that we're doing an RPM of about 725. And no voltage, of course. So now none of this is to be held to those exact numbers. These are just sort of general references. You may have a generator that's spinning at this RPM that's putting out 25 volts or 26 volts, and it could still develop enough of a charge in your charging system that it works perfectly fine. So don't say that these parameters are exact, but they give you a pretty good frame of reference. And I'll do it again. Just to give you an idea, I have another generator here, a Phantom 3 generator that's on the bench, and I did this test, and it was developing 31 volts. And some may say, well, this is a 12 volt system. Why is this generator putting out so much? And if you use the reference for wattage, volts times amps equals watts. So if it develops a lot of voltage, that can be added into the equation and take the place to some degree of amperage and still get to the wattage that you are desired to charge the battery. So that's, as I say, my general testing method before you take one apart and clean it and all that. And another thing I'll use as an example, the other one that I was testing, initially it didn't want to work. So then I started tweaking around with the brushes a little bit, and then it came to life. So that's another thing that it can give you a quick diagnosis on perhaps a brush that's stuck or not seating in all the way. So now the next step with this unit in the refresh stage is to take it apart enough to clean up the commutator, replace the brushes. I'll check to see if the bearings need to be replaced. If they do, they will be replaced as well. And again, we're just going to give it a refresh. Not really a serious rebuild. A serious rebuild would be going through a lot more work and effort. Perhaps we would call that a restoration, because we may also want to refinish the shell and any of the plated bits and give everything a really good cleaning up. Okay, so for dismantling, we have to take the water pump drive coupling off. There's a nut here, and then it's on a taper and a keyway. I usually don't use a whole lot of power tools with these types of things, but sometimes it just makes it a little easier. So we get that nut off. And as I say, this is on a taper, so it's really stuck on there. Now this may seem like a somewhat brutal way to take this off, but it's probably the least brutal way that I can find to get it off. So I just put a couple wedges right in there. Seat them in a little bit. And then we can give this a tap, and pop goes the coupling. So now, here's your Woodruff key. We need to get that out, of course. Then I'll bring you around and show you what it's like to undo the drive side. Again, I use a light impact. So we have a series of screws right here going all the way around the perimeter. We're going to take those out, and then that'll enable us to free up the other plate. I'll show you how that will work. Now we also have two screws here. This is a long reach screw, and it holds the attachment of the field coil connection to the post. There's supposed to be another long reach screw here, but apparently it's missing, and somebody probably just put in an ordinary type screw. So if we look in there, we may be able to see that. So we got to make sure to get those two out as well. So I will start with the long reach ones first. That's what they look like. It may be hard to retrieve this one. Of course, they're probably brass, which is non-magnetic. But if I get it loose enough, I may be able to use a holder screwdriver. Let's see. Hopefully it won't drop down. There it is. Now we'll take the screws out around the perimeter. For the ones that tend to be quite tight, I find that a long screwdriver like this tends to work very well. And they can take a little bit of effort. So be ready. And as in typical Rolls-Royce fashion, they're rather specialized, nice looking little screws. I believe they're solid nickel as well, with this 60-degree tapered head. Okay, so now we have these. So now we got the back drive plate off. Has given some results. And out comes the armature with the brush over in place. And we can see a bit inside of there. Okay. Lots of grunge and oil and other ugly stuff in there. I'll show you here in just a moment. Okay, so there's our armature. So now we're going to give this a good washing up. And we're going to give this a good cleaning too. You can see fuel coils look nice. There's just a lot of grunge in there. So we have the armature in a growler tester. And when I turn it on, you're going to see why it's called a growler. So basically what you do is you put the armature in as it's shown. Most growlers come with very specific instructions that'll tell you how to use it. So you put it in like that, turn it on, and you take a hacksaw blade and you follow it along these segments like that. Then you rotate. and you follow along again. And so this armature tests that it's good, fortunately. I'll show you what happens when you test an armature that's not good. So the segments become magnetic, and the hacksaw blade is attracted to it. So this is a bad armature. It needs to be rewound. Finding somebody to rewind armatures and do a nice job, I'm finding very difficult. Hopefully I'll find somebody because I do have a few bad ones. But so far I've been able to manage to get through the jobs I have. So now another thing I'm going to do with this armature, the next thing to do is to resurface the commutator, to clean it and to make sure it's good and round and doesn't have any ruts from the brushes. I'll set that up in the lathe and take a skim on that. I also like to polish up these surfaces a little bit. And yeah, so like I say, it's getting very, very difficult to find somebody to rewind these armatures properly. And the one thing I do want to stress is that there's some companies that'll work to a commercial standard, and you would think, well, that would be good, but Rolls-Royce worked to a much higher standard than what you would find in commercial standards these days. So there was a time where I sent one out for rewinding and it came back and all these wires were exposed and sort of bent in different directions. It worked. The armature worked, but it didn't look anywhere near as nice as this. You have all this additional securing and wrapping back here and up front here. And they did away with all that. They didn't, you know, when they stripped it down, they put in the wires and like I say, it worked, but it didn't look anywhere near as nice. So if you have a nice original working Rolls-Royce armature, then I say keep it as it is, because it's probably going to last a lot longer than when you have it rewound and they do a commercial standard rewinding. So I'm going to set the armature up in the lathe and we're going to take this trim off. Okay, so we have the armature set up. It's all been indicated, so it's spinning nice and true, you'll notice. And we're going to take just a few thousandths off of this surface, and then I'm going to use emery cloth to go over these just to make it look a little nicer, and it probably does help some. So we'll still have to take a few more thousandths off. I see some areas where we did not touch yet. Still a little bit right there, probably 3 more thousandths. I think it's going to be a total of like 13 thousandths to have taken off. Okay, so we're looking good. I'm happy with that. So we'll get our cutter out of the way here. Then we're going to go over these surfaces a bit. We're using emery cloth, and the nice thing about emery cloth is that it won't embed any grit inside of this, and that was the whole purpose of emery cloth. That's why it was developed, was that you can use it on things and not embed grit into it. I also like to get the ends of the shaft in case there's any burrs or scarring on it that can hang up the bearing. Okay, so there we go. Now we have a resurfaced commutator. Looking very nice. And we can move along to the next step. I forgot to mention that with the growler you also have this feature where you can see if any of the commutator bars are shorted to the shaft by touching each one of these. All of these are good. I'd already tested them. But again, I just thought I would demonstrate that. So we're now ready to bed the brushes. And I cannot emphasize just how important this process is. I don't think general generators and starters for other makes and models of cars need this step. I know a lot of rebuilders that when I refer to bedding the brushes, they think that they just put the whole thing together and run it for a while and the brushes wear into the commutator on their own. But for some reason we don't have that with the Rolls-Royce products. And so again, it is essentially very, very important to bed these brushes. I've had rebuilders call me on the phone and say I've done everything checks out, and this generator or this starter still doesn't work. And I say, well, did you bed the brushes? And they said, oh, we ran the thing for hours on the test machine. They should be bed. Well, no. There's a process, and this is the process that we've done and it has always worked. So what I've done was I've taken a piece of emery cloth, fine emery cloth, and I've stuck it onto the commutator. And I just use hot glue gun. I've been using hot glue gun a little bit more frequently here in the shop for doing things like this. Just you want to stick two things together quickly and easily, and you want to be able to take them apart again. Hot glue gun works very nicely. We used to use two-sided sticky tape. That works nicely. Maybe you can get emery cloth that has an adhesive. That works as well. You want to use emery cloth though, because you don't want any grit coming off and embedding into your brushes and getting into the bearings and causing problems. Sandpaper has aluminum oxide, and aluminum oxide is incredibly hard, and it can get into the workings of things, and it also it does not carry electrical current. Back in the old days, we used to use flint paper, but I can't find flint paper anymore. I don't know if it's still available or what. I don't know why I was always told to use flint paper. I think because the flint is a little bit better in case it got embedded into the brushes or in the workings of things. So that's what I was told, but emery has a good effect on this process as well. So yeah, so we have our armature in place. We drop on the brush holder like that. Then we put our new brushes in position. That's a strong spring. Make sure they work nicely on their own, and that they don't hang up. If you get a brush that feels tight, you can run it on a little piece of emery cloth on a piece of plate glass or a nice flat piece of steel or something, and take off whatever high spot or whatever edge is catching. And I'll show you, this is the old brush, and you can see that there was a fair amount of wear on these brushes. They would have lasted a little while longer, but now we'll even get more life. Now, hopefully you can see the brush there. So this is a brush that has not been bedded, and it does have a curvature, but probably not exact match. But I wanted you to see that so you can see the difference. Put that in. So now once we're in, then we rotate. I find that it's best to rotate around in one direction. If you go back and forth, it'll leave an odd pattern on the brush. You'll see carbon building up into the emery. After a few turns, take a brush out and check it. And then yeah, so when you look at it, you see that it's been making good clean contact. You don't have a spot that looks like it has not been in contact. So this brush is basically dead. So then what I do is I put it in place, but I put the spring in such a way so that it doesn't contact the emery cloth anymore. So then we check the next one. That one is the same thing. It has a nice, we got our curvature on there, and you can tell that it is making contact. So that one is done. Then the next one, and it too is, well, you can see a little bit of unevenness. So this one's gonna get another bit of rotation. Check this bottom one here, and that looks really good. So we'll leave that one out. So we just have that one more to do. Look at this other one more time here. Okay, looks like there's a little bit of an angle to it. So I think I need to go down a little further with the brush holder. I didn't want to force it too much. Then it's just harder to get off again. Alright, so yeah, went down a little bit more. And again. We'll check these two out. Okay, yeah, that's much better. And that one too. So now they're all bed. So now we can take the brush holder off the armature, peel off our emery cloth, and put this unit together and give it a test. So we're now at the stage where we can get this unit back together and test it. We have our commutator all nicely cleaned up. We have our new brushes in place and their bed. And we have this brush holder cleaned up. We're also able to get a lot of the slime and gunk out of the field housing, which will be a benefit of things. So we're going to start by getting the field housing back secured in the vise. Oh, and I should mention one other thing. We had that long reach screw, and then we had this other one which I thought was incorrect. But it is actually correct, because this screw could have stayed in place and not bothered anything. Anyway, I'll probably have to look on a drawing to confirm that. But I was looking at another Phantom 3 generator, and I saw it was the same arrangement. So yeah, so we secure our field housing. I'll trim this down so that you can see things a little better. Then we put our brush holder onto our, see, you needed that strap, so you needed to take that long reach screw out to get to that one, but we don't have that arrangement on the other side, so they just used a regular screw. So I don't think I really need to look at the drawing now. So yeah, so then we put this in place. I have a new roller ball bearing in here. It's pretty self-explanatory how to replace it. There's just 3 screws. Now this one is a roller bearing, I think, to help with alignment going this way. And I feel that the original Hoffman roller bearing in good shape is a much better option than buying a new one, because I think that back then they were of better quality than what you get nowadays. So now we slip this in position. And we want to make sure that we get this tab onto that stud. Closed, so you can start a couple screws. One there. We can set the brushes down in so that they'll be out of the way. Get this screw started. Sometimes you need to give it a little bump to center it up. So now we can connect up the brushes. I generally just put 2 screws in and then give the unit a test, just to be sure that I'm on the right track. It's also very important to make sure that the brush leads are going to run in a certain way that they're not going to hang up. Okay. Alright, so now we're going to give it a test. This fella. Goes. this guy in. And now we can give it a test. Get our meter connected. We have our ground. See, going to ground. I'm going to give it a spin. Now you'll notice that the voltage is a lot lower than what it was before. But there's a lot more loading on the drill. And when we look at the RPM is reduced considerably. So it's 310, whereas before it was about 410. So that's just to show the difference in the improvement, because when this spins faster from a stronger power source, the engine, then we'll know that that it'll be putting out even more amperage. So that's basically it. That's the key parts of doing a refresh of a dynamo, a 2-brush dynamo. I'm not going to go through and putting in all the screws and stuff. That's pretty self-explanatory. It's, you know, you just put them in one at a time as they came out. Make sure you align put your woodruff key in and align that and put your holder back on, and that's really about it. So I'll give it one more spin up just to show you what it's like. And so yeah, so when you have that heavy loading, you have the lower voltage. And just keep that in mind. So I hope you liked this video, and I hope you found it helpful for whatever you may be doing with your Rolls-Royce generator charging system or whatever it is. And if you feel that this is beneficial, I'd really appreciate it if you'd subscribe to my channel. It'll also keep you up to date on when I get a new video up.